This is Advanced Math, Unit 10, Lesson 3. Asymptotes and Domain is the title for today's lesson. Again, Unit 10, Lesson 3. Okay, before we get started on this, I want to quickly review something we talked in class about. And if for whatever reason you didn't get this in class, you need to hit pause and copy it down now because it is something we're going to use today. Previous lesson, limit as x approaches infinity from the positive or negative side. We did divide everything by the highest power of x, then take the limit. And then we talked in class about shortcuts. If it's top heavy, meaning the degree at the top is larger, it's always going to be does not exist. And we can check some in here. Let's see if I can find any that are, here's the one here. It's top heavy. There's the degree at the top is bigger than the degree at the bottom. We did all the work and sure enough it does not exist. Bottom heavy, meaning the degree at the bottom is larger. We have two of them here. According to the shortcut, the answer should always be 0. And sure enough, it happened. It's bottom heavy at 0, bottom heavy is 0. Here, the degree at the bottom is bigger, and the answer is 0. And the last one, same degree top and bottom. You take the leading coefficients. And let's see, we have one here. Same degree top and bottom, x to the 1, x to the 1. Leading coefficients, that's the 2 and the negative 1. 2 divided by negative 1 is negative 2. And we have another one right here. Degree is 2, degree is 2. Leading coefficients are the 5 and the 2, 5/2. Again, you can do all this work if you like, but we can now use the shortcuts, and we're going to use them today. All right. Number 1, y equals 1 over x plus 3. We're going to find the domain, vertical asymptotes, and horizontal asymptotes. And if I remember correctly, you have seen this before in last year's math class, in your Math 3 class. Okay, domain is just like what we've always done before. You take the denominator, what's going to make the denominator 0, negative 3. Therefore, you would say your domain is all reals such that x does not equal negative 3. All right, why? Because negative 3 plus 3 is 0, and 1 over 0 is undefined, so that's my domain. Okay, vertical asymptote is x equals negative 3 is the vertical asymptote. Okay, so let's make a little note here. How to find the vertical asymptote. How to find the vertical asymptote. It's pretty easy. It's what makes the denominator 0. Whatever makes the denominator 0 is going to be your vertical asymptote. Now it's plural because sometimes, like, don't write this down, but if you had something like this, you would have two vertical asymptotes, x equals negative 3 and x equals positive 5. So keep that in mind. All right, next one, how to find the horizontal asymptote, and that's the one that's a little new. How to find the horizontal asymptote. Now I know I put it plural a little bit here, but for the horizontal there will always be only one. There will never be more than more than one. All right, what you do here is pretty simple. You take the limit as x approaches infinity. And we're going to use the shortcuts that that I just talked previously about. All right, so let's go ahead and see how this works. Okay, we have that one, vertical asymptote. What makes the denominator 0? -3. The limit as x approaches infinity, you're going to use this. Is it top heavy, bottom heavy, or the same? Now 1 over x plus 3, the degree at the bottom is heavier, so we'd call that bottom heavy. Can you see that the degree at the bottom is 1 and there's no x's at the top? So we would say our answer is 0. And we do write y equals 0. Please remember that. For your verticals, you always write x equals. And for horizontals, you will always write y equals. Now, if you wanted to, you could do what I taught you initially, 1 over x over x, plus 3 over x. Reduce and take the limit. But it's easier if you just use the shortcut. Number 2, f of x equals 7x over 5 minus 2x. All right. Domain, I'm just going to put a D for vertical asymptote. I'm going to put a VA. And for horizontal asymptote, I'm going to put a HA. Domain, Va, and Ha. Okay, I'm going to box this one in. This was our answer on the last problem. Okay, domain, all real such that x cannot equal, you make the denominator 0. 5 minus 2x cannot equal 0. Subtract your 5, divide by the -2. That would give you positive 5/2. We will be graphing these eventually. Today we're just finding them. We will be graphing by tomorrow. Horizontal asymptote, vertical asymptote. What makes the bottom 0? We just figured that out. X equals. Kids often ask, are these two always the same? Most of the time, but not always. We will see an instance where it's not. It will be coming up in just a little bit. Okay, horizontal, we take the limit as x approaches infinity. So is the degree at the top or bottom heavier, or is it the same? Degree is 1, degree is 1. They are the same. So we take the leading coefficients. At the top, that is 7. Now be careful in the denominator. Its leading coefficient's not just the first variable. It's the, if you were to write it in standard form, the x would come first, so -2 is the leading coefficient of the denominator. So my limit as x approaches infinity would be 7 divided by -2. Don't forget your y equals -7/2. And that's your answer for number 2. All right. Number 3, f of x equals x plus 3 over x squared minus x d va ha. Okay, all reals such that x cannot equal. Okay, so we set the bottom equal to cannot equal 0. I can see that I'm going to have to factor that, take out a GCF of x, leaving behind x minus 1. And when I set the bottom equal to 0, I'm going to get 2 solutions. I'm going to have you guys give me a second. You can continue while I answer the phone. Hello, Mrs. Torres. Okay, sorry about that. X cannot equal 0. X cannot equal 1. If you put 0, 1, that's okay. X cannot equal 0 or 1. Nothing reduces. Vertical asymptotes, x equals, there's 2 of them, x equals 0, x equals 1. Because these are actual equations, they're equations of a line, I would like you to write these separately. If you put over here x equals 0, cannot equal 0, 1, that's okay. But here I want them written separately. Okay, horizontal asymptote. The limit as x approaches infinity. I look here, the degree at the bottom is bigger than the degree at the top. There's a 2 here and a 1 there. And if you look back at your notes, bottom heavy is 0. The limit as x approaches infinity will always be 0. So don't forget your y equals 0. again, if you wanted to, you could do what we learned the other day, x over x plus 3 over x, x squared over x minus x over x. In the end, you'd end up with 0, so it's easier if you remember the shortcut. Okay, number 4. F of x equals x squared minus 36 over x squared plus 6x. D va ha. All right, all reals such that x cannot equal, and again I have to factor. I could take out an x, leaving behind x plus 6, and I can factor the numerator. And does it matter if I factor? Let's see. Yes, it matters because I'm able to reduce. But before you reduce, this is where these two do not always end up the same. You find your domain before you reduce, and you find your asymptotes after reducing. Let's write that down. Okay, what did we say? Find domain before reducing, and then we find vertical, we find everything else after, not just vertical, but everything else. Find everything else after reducing. Now I say everything else, even though there's right now only 2, but there's going to be more. There's going to be x-intercepts, there's going to be a slant asymptote, and we'd find all of that after reducing. The only thing I do first is the domain. X cannot equal 0 or negative 6. So if you wrote it like that, that's okay. X cannot equal 0 or negative 6. I'm hoping that makes sense to you because there's 2 restrictions here that x cannot equal. Then you reduce, and I have x minus 6 over x. Now I'm going to do everything else. Vertical, what makes the bottom 0? There's only one thing in the denominator now because this is the function I'm using. So x equals 0. So this is the rare case where these two are not the same. See, there's 2 of them here, but only 1 here. This means when we get to our graphing day that there will be a hole in your graph. When you have your graph, you're going to have a hole in the graph is what that means. Let me just show you a picture of it really quick. You can see here we have 2 restrictions for our domain, but only 1 vertical asymptote. When that happens, you have a hole in your graph. Okay, so with that being said, x is 0, horizontal asymptote is it top heavy, bottom heavy, or the same. The degree at the top is 1, degree at the bottom is 1, so we take our leading coefficients. There's a 1 there and a 1 there, and 1 over 1 is 1, so y equals 1. All right, to make sure you are ready with questions, we have just a few more to get through, different types. This next section is find the x-intercepts, which should feel like review. It is. Find the x-intercepts. I'm going to put parentheses here, zeros. You might say find your zeros. Okay. Remember, we should know already when we do this, we set y equal to 0. We just did a whole lot of that in our last unit. Number 1, f of x equals x squared minus 9 over x plus 1. Set it equal to 0, because that's how we find x-intercepts. And I'm hoping you recognize that we're going to multiply both sides by x plus 1, because I'm trying to solve for x, so I'm going to get it to the other side, or think of cross-multiplying, if you will. That's gone. Distribute your 0, it's still 0. X squared minus 9, I'm going to factor to x plus 3, x minus 3. If you don't want to factor and you want to move your 9 over and square root, that's fine. In the end, you end up with the same answers. X equals negative 3, positive 3, or plus or minus 3 if that's the way you wrote it. And those are my x-intercepts. And we will be doing graphing this eventually, so you want to make sure you understand. Number 2, g of x equals 5x plus 3 over 2x minus 1. Set the equation equal to 0. 0 equals 5x plus 3 over 2x minus 1. Multiply both sides by the 2x minus 1. Gone. 0 times 2x minus 1 is just 0, leaving behind 5x plus 3. Subtract, divide, you get negative 3/5. So here we have two intercepts, here we have only one, and that happens. Sometimes there's more. That's it. That's what you're going to be doing. And I'm hoping you recognize in both of these cases, the denominator didn't really have any effect. You're really just setting the top equal to 0. Do you see that? You can factor x plus 3, x minus 3. Here, same thing. You can just solve that and subtract, divide, negative 3/5. Why is that? If I'm trying to figure out when this is 0, the only time a fraction will equal 0 is if the top is 0. The bottom can never equal 0. So the bottom really doesn't play a factor when I'm finding my x-intercepts. Okay. Unless it's written like this, f of x equals 5 minus 3 over x plus 7. Because there's two separate fractions, I can't use the shortcut and just ignore the bottom. Because there's two separate pieces here, two separate terms, I can't use the shortcut that we talked about up there. Okay, 0 equals 5 minus 3 over x plus 7. And we clear a fractional equation just like we would clear a complex fraction. Or you can just subtract. It's up to you. You can clear it by multiplying everything by x plus 7, or you can move your 5 over. I'm just going to move the 5 over. If you want to clear it and see if we end up with the same answer in the end, that's fine. Subtract. Negative 5 equals 3 over x plus 7. And again, I have one term here now, one fraction. I still cannot use the shortcut though because that is not 0. If that was 0, I could ignore the bottom. But it's not 0, so I'm going to multiply both sides by x plus 7. Distribute. Negative 5x minus 35 equals 3. Add your 35 over. Negative 5x equals 32. Divide the negative 5, and you end up with x equals negative 32 over 5. And that is it for this lesson.